In this video, we will be learning about projection of planes, which is an important topic in the engine drawing. So in order to understand the projection of planes, you need to understand the what is meant by orthographic projection. You need to understand what is meant by projection of points. You need to understand what is meant by projection of lines. Then only you can understand the projection of planes. Okay. Then only you can understand the projection of planes and you can practice some questions. So whenever I say a plate, lamina, or plane surface, plate, lamina, plane surface, both are refers to the planes only. Both, all the three terms refer to the planes only. Whenever I say a plane, it has a two-dimensional, which is having the length, width, and it suppose it has a thickness, then it will have the negligible thickness or zero thickness, or either 1 or 2 thickness it will have, which is called as negligible thickness. Okay, in the problem they can say either lamina, plate, or plane surface. Everything is same. Okay, so you need to know what are different types of planes. So first is a triangle. So it has 3 sides. Square, it has a 4 sides and all the sides are equal. And rectangle, all the sides are equal. In the rectangle, two sides are opposite sides are equal, and it internal angle is 90 degrees. And in square, all the sides are equal, internal angle is 90 degrees. And rhombus, all the sides are equal, but the internal angle but the angle comes as 45 degrees. With respect to external, this angle comes as 45 degrees. Okay, external angle comes as 45 degrees. Okay, here the external angle comes as 90 degrees. Here also the external angle comes as 90 degrees. But in rhombus, you will get an angle of 45 degrees. This angle will be 45 degrees. With respect to horizontal, the angle is 45 degrees. And next is the polygons. You can use in the problem they can ask different polygons, pentagon, hexagon, and they can ask about circle and ellipse. There is a special case. If you rotate circle, if you give either theta or phi, it will have the projections as an ellipse. So in the problem they can ask that in the first stage it is a circle, and the third stage it is an ellipse. So with respect to ellipse dimensions, you have to draw, you have to generate the projection of planes you have to make. Okay, and the possible orientations of planes. So there are different possible orientations of plane surfaces. First one is plane is parallel to HP and perpendicular to VP. So I hope everyone know what is meant by vertical plane and horizontal plane. So this is my vertical plane and this is my horizontal plane. And here, whenever I say a plane is parallel to HP and perpendicular VP. So if you see this line is parallel to HP and this line is perpendicular to VP. This means I can see a point on the VP, but I can see the complete line on HP. And next is the reverse case. In this reverse case, the plane is parallel to VP. So this plane is parallel to VP and I can see a point on HP. Okay, so it is another perpendicular to HP. And in the next case, it is plane is perpendicular to both HP and VP. So the plane will be both perpendicular to HP and VP. Suppose I am taking a plane called triangle. Suppose I am taking a plane called triangle. This triangle, I can see the true shape on PP. PP is the profile plane. So I'm seeing the true shape on profile plane, and this line is, and it is perpendicular to HP and perpendicular to VP. I can see the true shape. Whenever it is a plane surface both perpendicular to VP and perpendicular to HP, I can see the true shape on the profile plane. Okay, and surface plane inclined to VP, so it is making an angle phi. Whenever it is inclined to VP, it is making an angle of phi, and whenever it is an making inclination to HP, it is an angle theta. So you need to know what is the inclination of angle theta and phi. This you will be learning in the projection of points and projection of lines. Next is plane is inclined to both. So here in this problem, you have to solve the problem based on theta and phi. Both angles are given. You have to solve. In some cases, first will be theta, next will be phi. You have to give the angle. In some cases, first you have to give the phi, next you have to give the theta. Okay. And so there are mostly two cases: plane is parallel to HP or plane is parallel to VP. So I'll be learning what is the case parallel to HP. Suppose I'm taking a square. Suppose I'm taking a square of the side ABCD, and in the problem, I'm considering for the plane, I'm considering only one edge. This edge is AB. So even though they say that plane is parallel to HP, we will be considering only one edge, AB. This AB is parallel to HP and perpendicular BP. So whenever I say parallel to HP, there are two cases. So whenever I say parallel to HP, there are two cases. So this is my HP. So this is whatever I'm drawn here. So this is my HP. So in this HP, this line is parallel to HP and this line is also parallel to HP. But this line is parallel to HP and perpendicular to BP. This line is parallel to HP and parallel to VP. There are two cases. So here, whenever I say parallel to HP and perpendicular to VP, then I'm considering only this side. This side or edge is parallel to HP and perpendicular to VP. Okay. And next, parallel to VP. So whenever I say parallel to VP, then this line or this line is parallel to VP and it is also parallel to HP. This line I can see parallel to VP and also parallel to HP, both the case. So in some cases, if they say that it is only parallel to VP and perpendicular to HP, so what you have to draw? Same case, you have to draw it as a, first draw the vertical line, then you have to draw the hexagon shape, take internal angle as 120, and then you have to complete this shape. So in some cases, whenever the plane is parallel to VP and perpendicular to HP, so on this case, I can see the, on my VP, I can see the true shape, but on my HP, just I can see this as a point. This projections will be as a point, this projection as a point, just a line I can see. So this complete line I can see just as a point on the, on this HP. So if I'm considering this edge is parallel to HP and perpendicular to VP. If I'm considering this edge is both parallel to HP and VP. And if I'm considering this edge, so this edge is parallel to VP and perpendicular to HP. Okay. And there are, I've told that there are different shapes, different plane shapes, and you need to know what are the labeling, how to give the labeling, you need to know, and what is the orientation. And if I'm projecting on the front view, if the any point is projecting on front view, I have to give small letter. Suppose this A is projected on the front view, then I have to write small letter A and dash. This A is projecting on top view, then I have to write it as A. So this is my XY line. So with respect to XY line, on the front view I have to represent as A dash, on the top view I have to represent as A. Then I'll show you what are the different shapes, what are the labeling. Suppose I take a triangle, it has 3 ABC. If I take a square, ABCD. If I take a rhombus, ABCD. Suppose if I take a circle, then I have to divide the circle into either 8 parts or 12 parts. Those are the called as standards. Then if I take a pentagon, 5 sides, ABCDE. If I take a hexagon, ABCDEF. So like that, you have to make the orientation. Okay. So this is the orientation. So all the cases, in all the cases, plane is parallel to VP. I took all the cases which is plane is parallel to VP. So if I say a triangle, then I can see the triangle plane parallel to VP. Then I can see just as a line on HP. So here A dash, B dash, C dash. This is my AC side. Suppose AC side is 30. Then I have to draw here ABC. Okay. Similarly, circle. So this circle lamina, is parallel to VP. So that I'm dividing this circle into 12 equal parts. A, B, C, D, E, F, G, H, I, J, K, L. L is nothing but the 12th part, 12th dash. Okay. Either you can, if it is a plane, you can give it as either numbers or alphabets. Better give alphabets only. Don't give it as number. Don't give 1 to 12 dash. Don't give only the alphabets. A dash to L dash. So because it is parallel to VP, then on the XY line, here I'm considering that H equal to 0. It is resting. All this parallel to VP, the sides are resting on VP. So whenever a side is resting on VP, H is 0. Whenever a side is resting on VP, whenever a side is resting on HP, whenever the side is resting on HP, H is 0. Whenever the side is resting on VP, D 0. So these are the things you need to remember. Okay. So here it is resting on HP. So H equal to 0. So we are assuming some D value. then this is the case. Suppose if a rectangle is resting on HP and it is parallel to VP, then A dash, B dash, C dash, D dash. Here I can see A comma D, B comma C. Next is the rhombus. So any problem they can ask. So the rhombus is resting on HP and parallel to VP, A dash, B dash, C dash, D dash, A, B comma D and C, because B and D are coinciding. So whenever you are drawing a rhombus, make sure that B and D are coinciding, and whenever you are drawing a circle, B and L will be coinciding, C and K will be coinciding, D and J will be coinciding, E and I will be coinciding, F and H will be coinciding, and A and G doesn't coincide with any of the number. These two are separate. Extreme ends A dash and G dash. Similarly, a square A dash, B dash, C dash, D dash. So in square, A and D are coinciding, B and C are coinciding. And next, coming to the pentagon. So this pentagon is nothing but the corner is on VP. So corner is resting on VP. So first I have to draw the corner. With respect to corner, I have to extend my pentagon. Okay. And in this case, you have to know what is the internal angle of pentagon, what is the internal angle, external angle of pentagon, hexagon, you have to know. So how to calculate internal external angle? So whenever you want to calculate, suppose for pentagon 360 by 5. Pentagon has number of sides, you have to calculate. So in this case, it is 360 by, in this case, it is 360 by 5. Suppose if you don't know what is the internal angle I have to take, what is the external angle I have to take, then you have to take it as 360 by 5. Okay. So 1s are and 7s are. 7 is 35. Again 10. So 5 will take at 2. So 72. So the external angle comes as 72. Okay. So you want to find the internal angle. Internal angle is 180 minus 72. It comes as 108. Okay. So whenever I'm drawing a pentagon, I have to take internal angle as 108. Okay. So this angle is 108. This angle is 108. This angle is 108. And this angle is 108. So like that, you have to take the internal angle. Suppose similarly 360. Suppose it is a hexagon 360 by 6. So 360 divided into 6 times. So 60. So if I take a hexagon, the external angle is 60. Therefore, 180 minus 60, it comes as 120. So here I have to take internal angle 120, 120, 120. Compulsory I have to take, and sides are, it is a regular polygon. If I measure the side between F and E will be same, E and D will be same, D and C will be same, B and C will be same, A and B will be same, and A and F will be same. All the sides are equally, because it is all the problems what we are dealing, it is a regular polygon, all the sides are equal in this case. Okay. Yeah. So in this case, so I'm saying pentagon is resting on corner. So I have to draw the corner first, then I have to make this one, then I have to take an angle of internal angle, and I have to use this one. In the next case, the pentagon edge is on VP. So now we have to consider the edge, either this side or this side you can consider. So I'm considering a point. I can consider point from the top. I can consider point from this side. I can consider point from this side. Anything I can consider. So this edge is resting on VP, and it is the edge is resting on HP, and therefore H equal to 0. So D I'm assuming. Okay. And this edge is okay. Yeah. So here in this case, the edge is on VP. Okay. So here we will be taking, this is the side. First I have to draw my side here. After drawing the side, I have to take the internal angle as internal angle 108, 108, 108, 108. Then I will get a pentagon. Either or else I can draw side this side. I can take the internal angle 108, 108, 108, 108. Then it will be completed. Okay. Next is hexagon corner is on VP. So corner is on VP. Okay. So here the corner is on VP. So I'm from this corner, I have to start. I have to take an 120 degrees, then I have to 120 degrees. Then if I take 120 degrees, it will be a horizontal line. It will be a horizontal line. Then I have to close it. All are regular polygons. So all the sides are same. Okay. And next, edge is on VP. So whenever the edge is on VP, so it is at a certain height. So from here I have to draw. already whatever I have shown. Take an angle of 1. First draw the edge, make it as AB, and then take an internal angle of 120, 120, 120, 120, and 120. So this is the same thing. Give the labeling in the front view: A dash, B dash, C dash, D dash, E dash, F dash. Generally, whenever we are making labeling, the labeling should be in counterclockwise direction. The labeling should be in counterclockwise direction. The labeling in should be counterclockwise direction. The labeling should be counterclockwise direction. Okay. So we consider counterclockwise labeling as positive. So every time give the labeling as counterclockwise direction. Okay. Yeah. So in all this case, everything is resting on VP. All this case, everything is resting on VP. Therefore D equal to 0. Therefore D equal to 0. And H we have to assume some value. H I'm assuming it as 20 mm. So minimum distance, what are the minimum distance I'm assuming? That minimum distance should be 20 mm. For each and every case, I have to assume that it is 20 mm distance, and then you can draw it. Okay, so if I'm taking this side, this should be the minimum 20 distance. If you are assuming 20, then this will be 20. So you can assume any value, 5 value, 10 value, 20 value, depending upon your sheet size and dimensions. How many questions you want to accommodate in the sheets, you can give your own. You can assume. This is assumption you can make. This one. Okay. So I hope everyone understood.